Hey guys, welcome back. So let's continue from where we left off in last video. So during last couple of videos, we discussed quite a bit of theories about what we are going to do today, which is built in the back end of our mythical misfit web application. So this is the part 8, and today we are going to actually implement the back end. And since we already know the theoretical part, so it will be very easy for us. So let's get started. So I'm heading over to AWS Modern Application Workshop GitHub repository. So as we have already mentioned, this is an official workshop launched by AWS, and we are at module number 2. So when it comes to hooking up our backend, which is running inside a container, we have to do two main things. First, we need to set up the infrastructure or the environment, and then create the containers, build it, deploy it, and manage it. So we are going to do it in 2 steps, and let's start with the first step. Environment setup by provisioning the core infrastructure. So in our infrastructure, we will have a VPC, 2 NAT gateways, security group, IAM role all associated with the VPC constructs, and a DynamoDB VPC endpoint for our containers to communicate with the DynamoDB in a later module. So we create all these resources using a CloudFormation script. So it's just a matter of running this line of code to get the CloudFormation script running and provision all this. And then our part 1 is completed. Hey guys, before we jump into the implementation, a quick word of warning. Since we will be using many AWS services in this video, AWS is going to charge you if you kept running all those services for some time, right? So if you don't want to incur any charges, once you are done with this video, please remove your resources. So let me just copy this line of code and head back to my IDE. And we are using Cloud9 IDE. And I'm going to paste that line here. So it's basically AWS CloudFormation. And we are going to create a new CloudFormation stack, which is called Mythical Misfit Core Stack. And we are enabling the IAM capability, otherwise we cannot set IAM roles. And as for the template body, this is where we are referencing our CloudFormation script. So it's currently referencing our AWS Modern Application Workshop, module number 2, CFN core.yml. So let's go to module number 2, CFN core.yml. I shall open up the core.yml script. Let me get a little bit of real estate. Alright, so here we have some information about our IP ranges for our VPC and our subnets, and we are going to spin up public subnets, rather 2 public subnets and 2 private subnets. And here are its IP ranges. And if I go to subnet config section, it will show IP range of our VPC. It's 10.0.0.0/16. And by the way, guys, we discuss all these construct and how they connect with each other. Why do we need a public subnet, private subnet, NAT gateways, and all this information in last couple of videos. So that's why like those 2 videos had to come first before this implementation. So if you haven't checked them out, I'll put a link down here. So this is the important section in the CloudFormation stack. So this is the place where we will define our resources. So as for our first resource, we are going to define our VPC. It's the type of AWS EC2 VPC, and for the CIDR block, we are referencing subnet config that we define up here. So it's a mapping that it will check and refer. It's going to refer VPC here and the CIDR, which will give out this 10.0.0/16 value in return here. And similarly for our subnets as well, we are referencing the same map. For example, have a look at this public subnet 1. For our CIDR block, we are again referencing the same map and referencing public 1, which is this, and return that CIDR value. So likewise, we configure all our subnets, subnet number 2, the public subnet number 2, and private subnet 1 and private subnet 2. With that, our subnets and VPC configuration is done, and then we'll go to our next resource, which is an internet gateway. We know why an internet gateway is there, basically to let the resources connect to the internet. And inside the internet gateway, we will attach it to a particular VPC. So we are referencing our VPC that we just defined above by using the ref keyword. And for our internet gateway, we have to define public routes in a route table. As for a public route, we will say, okay, any traffic that is going out to any IP address, please take them to the internet gateway. So that all the traffic destined to outside will go through the internet gateway. And then we are going ahead with the configuring our NAT gateways. It's basically in this module we are spinning up two NAT gateways for our containers in the private network to connect to the internet and pull down the Docker images and other security updates. And as we already know, these NAT gateways, we define it inside the public subnet and we update the route table of our private subnet to direct any traffic that is bound to internet or any IP address, take them through the NAT gateway if that IP address is not within the range of VPC. So if this explanation is a little bit confusing for you guys, I invite you to watch my previous two videos, which I will go in depth about each of these services and the purpose of them. Alright, so now let's pull up our console and execute this CloudFormation script. So I'll hit enter. I got a stack ID written, so that means my stack has started provisioning. So let's have a look at on the CloudFormation page. So I'm in CloudFormation service. Let me do a refresh here and you can see stack creation is in progress. So I can click here and look at the resources that is being provisioning. So it has already created my DynamoDB endpoint, ECS task roles, service roles, and private route table, and VPC creation is also completed. Very nice. So it will take about 5 to 10 minutes to complete this whole stack, and once you complete it, we can inspect all the resources inside the output section. Right now there's nothing. So I'll come back in 10 minutes. Alright, now our stack is completed. As you can see, now output section is populated with a lot of outputs that we have defined in the CloudFormation script. Now these outputs we're going to be using in our application. Now from the CLI also we can access these outputs. So if I just go into Mythical Misfit IDE, I can use CloudFormation describe stacks command. So it's basically AWS CloudFormation describe stack and the stack name is Mythical Misfit core stack, and let's hit enter. So with this command it's going to output all the output names and values. Now since we need to use these values, let's put them into a particular file. Let's clear out the screen and up arrow once, so you will get the same command describe stacks, and we are going to put that into a file called CloudFormation core output.json, which is going to be created at the root level. So we are just copying all that content into this file. So let's hit enter. Now as you can see, the new file is now created and we have got all the output values here. Great. Now that our environment is created, let's move ahead with the second part of this module, which is deploying the service with AWS Fargate. And in this part, we are going to build the Docker image first locally, and then we'll push that Docker image onto AWS ECR or Elastic Container Registry. Basically, you have two options. Either you can push that image into ECR or you can push that into Docker Hub. So in this workshop, we are going to use ECR. And after that, we'll use AWS ECS or Elastic Container Service to create a service of AWS Fargate type, so we don't have to manage any resources, and manage our containers with a load balancer in front of that to balance the load across the multiple containers that we are going to deploy in our cluster for high availability. Alright, so let's get started. So it's about building a Docker image. So in order to build Docker image, we need to have a Dockerized application. So where can we find a Dockerized application? In our Mythical Misfit application, if you go to into module 2, you should see there's a folder called app. So in the app, another folder called service. So in this service, there's the file called mythicalmisfit.py or Python file. It's basically a Python Flask application. Now, Python Flask is a very lightweight framework for Python web servers. And in this simple web server, you will see two routes. The first route is slash. So if there's a request that is coming into this backend server with the path slash, it's going to return this message, nothing here, used for health check. Basically, we need a particular route for our health check in the load balancer. And there's another route, and that's called slash misfits. So it's nothing but returning misfit creatures information from this misfit slash respond.json file. You can see slash misfit hits. It's going to open this file and read it and then send the response back to the user. So let's look at this particular file, misfit slash response.json, which is this one. And it's an array of objects of mythical misfit creatures. So later on we can change this information and see if that actually visible in our web application as well. Now later on we are going to hook this up with a database and so on, but for now this is enough for running our containers and see if everything works with our backend. Okay, so how can we Dockerize this? So along with this particular service, you should see a file called Docker file. So this is the file that will dockerize that Flask application. So we are going to use this Docker file to create a Docker image locally and test that locally first. And if everything works, we'll push that Docker image into AWS ECR, and then we can use that to create our ECS service. So let's test this locally. So let me expand my terminal, clear the console out. You can simply cd into environment slash AWS Workshop slash module dash 2 slash app. And inside it, you should see there's a Docker file. So let's first build the Docker image locally with this Docker file. So how can we do that? It's basically Docker build command, Docker build space dot. So what does this dot represents? It's the context. It says basically look at the current folder and find the Docker file and use that to build the Docker image. So let's hit enter, and it's going to take a little bit time to run through all the steps that we have defined in the Docker file and build the image. In my case, it built instantly because I have built it earlier. Right. So once you have built it, you should see it is returning the image ID at the bottom. Now, if we need to run this Docker image and create a Docker container, we have to use this image ID. So let's clear the screen and try to run a Docker container locally within our Cloud9 IDE environment. I will type Docker images. That will give me all the images that is being built. And you can see here's an image that I previously built. So this is the image ID that we are going to use to spin up the Docker container. So let's type docker run -p. We are going to map the host port 8080 to 8080 container port, so we can access our containers port 8080 from our host with the same port number. And then leave a space, and we need to paste the image ID. I just copied it here and paste it. In your case, you can also get the image ID and paste it here and hit enter. So that will spin up our Flask application server in the container and expose it outside with port 8080 in the host. Alright, so let me minimize the terminal. So now our server is running on port 8080. Let's test this. So with Cloud9 IDE, you can easily test it if you go to preview section here and click preview running application, and it's going to open up a integrated browser here, and I can expand that browser as well and look at the address bar. Now this is the server URL that our container is running in our Cloud9 IDE environment. So this is basically the host. And if I go to slash, you should see it's called nothing there, use for health check. Try slash misfits instead. So let's try misfits and hit enter. And there you go. I got all the data from that JSON file. Now this Docker container is working fine in the Cloud9 environment. So let's push this Docker image onto ECR so we can use it within ECS. Now before that, guys, we have to tag our Docker image. Currently we haven't tagged it yet. So let's build this again. Docker space build, then the context dot, and then we'll add a tag -t. So that's a specific format, guys. You can simply find it in the documentation. It's here. So it's docker build -t, and you have to copy this string into here and make sure you replace the account ID and the region. So currently I am in US East 1 region. So I'll type US East -1 and the account ID. Well, if you look into the CloudFormation core output JSON, which we have created, you should see the account ID here. Make sure add your own account ID and now hit enter. Okay, it says now it is successfully tagged. So let's check our Docker images. So we have this very lengthy tag. Nice. Now in order to push it to ECR, first we need to create a ECR repository. So let's follow along. If you scroll down here, pushing Docker images to Amazon ECR. So just copy the command here. So I'll copy it and get over to the terminal and hit enter. And now it's created. So it returns this JSON response. If I go to ECR and do a refresh, I should see the repository is now created. Okay, as for the next step, we need to log in to this repository. So in order to log in, use this command So it's basically AWS ECR get login, paste in the command and hit enter. Then you should see the message login succeeded. Now we can push our images to the repository. In order to push an image to ECR, we have to type docker push and the image tag. So let's first get the image tag, that long one, this one. So I will just copy this and type docker push and that long image tag and now hit enter. Now it's pushing our image to ECR. Alright, it's completed. If I go to ECR and click on my repository, and I should see the image. Here we have. Alright, so congratulations, you have pushed your image to ECR. So what's next? Now we need to use this image and make containers and then maintain them in Elastic Container Service or ECS cluster. So we need to first create an ECS cluster and then we'll create a task definition with this image that we just pushed into ECR, and then we'll create a ECS service stating how many number of containers that we want to up all the time, and finally we'll spin up a load balancer and balance the load across those number of containers. So first step, let's create the ECS cluster. Okay, so under create an ECS cluster section, you can see the corresponding command AWS ECS create cluster. So just copy this and in the terminal I will paste it in. So it's basically creating a cluster called mythical misfit dash cluster and hit enter. So the cluster status, it says it's active. Now we can go to ECS. Currently I have only the default one. If I do a refresh, there we have, I have my empty cluster right now. Now along with this, let's create a log group as well, since we are using AWS Fargate and those are managed container compute. We don't have a specific access to those servers. So if you want to do a debugging, you can use logs that is in the log group. So I'll copy this command as well and clear the screen and paste it in and hit enter. Oh, it's already created in my case, so in your case you won't see that issue. Let's move on to next step. It's about creating the task definition. And we already mentioned that the task definition is like the blueprint for our containers, right? So they have given a template for the task definition in the task definition.json file. So let's open that. So that's in module 2 AWS CLI. You have task definition.json. So this is the CloudFormation template for a task definition, and there are some placeholders we need to fill up. So if we quickly go through the attributes, you can see it's the CPU power of 256 and with 512 megabyte memory. Using AWS VPC network mode, we dive a lot in this network mode in the last couple of videos. And we are using Fargate as the managed compute platform for our containers. And here we have to replace the execution role. So this is basically ECS execution role for ECS service to talk to other services. Now we can find that very easily in ECS service role ARN, and we can find this in CloudFormation core output file. So you can find the corresponding value for replace me ECS service role ARN. It is this one. Let's copy this and in the task definition file replace. And also the task role ARN, replace me ECS task role ARN value. So let's go there. And here's the corresponding name and this is the value. So copy this ARN and replace it here. And for the container definitions, we have to specify the container image, which we have already pushed into ECR. So here, let's replace the tag. So I can go to ECR. And this is the image URI which we set as the tag for this particular image. I copied it and replace it here. And finally, the region US East 1, North Virginia in my case. Okay, let's save this. And now let's create a task definition using the CLI. So if you scroll down a little bit under register ECS task definition, you can see the command here. Just copy that and get the terminal up and paste it. So it's basically AWS ECS register task definition command, and we are referencing the file we just edited. Okay, and hit enter. Okay, so it says it's successfully created, And we can verify that if you go to ECS service and go to task definitions, and you should see it's created here. All right, so now we have a ECS cluster and a task definition. In order to run the tasks and maintain that, we're going to need to create a ECS service. And apart from that, we are going to spin up a load balancer that route traffic to all the containers managed by our ECS service. So let's first create our load balancer and then configure the service. I know it's a lot to digest in one video, but anyway, let's do that. And in the following video, we'll do a review on everything that we have done in this particular video. All right, so back to the documentation. So it's about enabling load balancing, and we are going to create a network load balancer. And we talked about several load balancers, application, network, and classic load balancer. In this guide, they have chosen network load balancer. So this is the CLI command that we need to create the load balancer. Now copy that, clear the screen, and paste that in. And we have to replace few things in this command. So if we look at closely, so this is AWS, then the ELB version 2, and we are going to create the load balancer with the name of misfit-NLB, and this is going to be an internet facing load balancer. So the scheme is internet facing, and for the network we have to provide our public subnets IDs. See, first the public subnet 1 and the public subnet 2. Why do we need to have our load balance in the public subnet? Because it is the first point of contact for all our traffic, right? So that has to be in the public subnet where anyone can access over the internet. So let's replace public subnet 1 and subnet 2. So this time I will go to the stack details directly from CloudFormation. Public subnet 1. So I'll copy the subnet ID and paste there, space, and for public subnet 2, I will get the public subnet 2 ID, which is this one, and replace here. And whatever the output, we are going to copy it to a file called output.json, nlb-output.json. So let's create this. Okay, it looks like it's created, and we have the nlb output.json. So here we have the ARN of the load balancer. Okay, so now we created the load balancer. What is the next step? Now it's time to set up our listeners for the load balancer and the corresponding target groups. So we already discussed this. The listeners will listen to the traffic coming from the internet, and it will listen on the port and the protocol, and the listener has rules, and it will evaluate the traffic against those rules and then send it to the corresponding target group. So in the target groups, we will set our container IP addresses as targets. So our load balancers can directly forward the traffic into the container. Okay, so first let's create the target group. I will use this command here. It's a bit of a long command, but let's have a look. Paste it in. It starts with AWS create target group because we are creating target group, and the name of that target group is mythical misfit-target group. And as for the protocol, we use TCP, so we capture all the TCP traffic, and the target type is IP. You see, if it is a classical load balancer, the target type could be instance or EC2 instance. So in this case, since we are using AWS VPC network mode, we are using IP target type. And then we have to replace the VPC ID here. So let's quickly do that. I will go to CloudFormation, and under VPC ID key, you will find the value here. Copy that and replace here. Then we have health check intervals because any load balancer will do health checking. So it's doing the health check in every 10 seconds. And the health check path is slash. Now, if you can remember, we have a particular route for slash in the container that is returning some text back to the caller. So that is specially for health checking. And health check protocol HTTP, and healthy threshold count it's 3, and unhealthy threshold count it's 3. That means if 3 times the target doesn't respond with a healthy response, it's considered as unhealthy, and afterwards it will wait until target returns 3 healthy responses for ALB to mark that particular target as healthy again. And finally, we are sending the content into target group output.json. Okay, it's successfully executed, and in the target group JSON, I should see the return output. Very nice. So we have the target group. Now we need to create our listeners. So let's copy the create listener command. I will just copy it here and take my terminal, clear the console and paste this in. So it's again using create listener command, and for the default action we are using the target group. So what is this default action? That means we are not applying any rules or so. By default, any traffic will be forwarded to our target group. So which target group? So we have to specify the ARN of our target group here, which we already have, right? So that is available in our target group output.json, which we just created. So copy the ARN and I will paste it in, and we have to reference our load balancer ARN here as well. So let's replace our ELB ARN. You can find it in NLB-output.json, and here we have load balancer ARN. Alright, I pasted that, and let's hit enter to create the listener. Beautiful. So it's created. So let's check this query quickly. I will quickly go to EC2 service, and there you will find load balancers right here. And in load balancer, you can see our load balancer is now created. If I go on to listeners, you should see my port 80 listener, which forward request to mythical misfit target group. So everything is now connected very well. So what's the next step? So now that we have the load balancer that is sending the traffic into the containers, it's time to manage our containers. So we do it with the AWS ECS service. So it's time to create our service. So I'll use this command. So this is to provide authorization for ECS to create an ECS service. So I'll hit enter. So I got an error. It says this has been already linked with this account because I already created it. So in your case, this wouldn't be a problem. So let's move on. And in order to create the service, we are going to use another template. So the template is available at service-definition.json in AWS CLI folder. So let's go to AWS CLI folder, and you should see service-definition.json. So this is the place that we tell our service which task definition are we using. So here it's the task definition of mythical misfit service, which we just created earlier. And then we have some placeholders to fill. For example, the security group. Since we are using AWS VPC mode, we are spinning up these containers in the context of our private subnets. So in order to control traffic into our containers, we have to set up a firewall, right? So virtual firewalls in AWS is called security group. So we have to replace the security group ID here so that we can find it in our stack details. If you go to here, you should find the key Fargate container security group. So let's copy the security group ID and replace it here. And we have to add our two private subnetworks because our container is running in the private subnets, not in the public subnet. Make sure you choose the correct keys and the correct values. Private subnet number 2, or let's take number 1 first. Private subnet number 1, this one. The order doesn't matter anyways. And for the subnet 2, it's this one, and replace it. And we have to set up some configuration onto the load balancer as well, especially the target group ARN, right? So we can find our target group ARN right here. So this is our target group ARN. Copy the value, paste it here, and save the content. Now we are good to go. And now let's use this command to create the service with the template we just have filled. So I'll take the terminal and paste it and hit enter. Nice. So it's created. You can just double check it. If you go to ECS and if you go to clusters, and you should see there's a one service is running in our mythical misfit cluster. Go into that, and here's our mythical misfit service, and you can see the task definition is correctly set and desired count is 1. So we are expecting only one container and still pending. So let's go to our tasks. Let's see if the task is running. Well, the task is already running. Very nice. So now our service will make sure at any point of time the desired count is 1. If this task got failed, it will spin up a new one and maintain the desired count. Of course, we can increase the desired number of containers we want, but for now, let's continue. Okay, now it's time to test our service. So we can simply test our service by talking to our load balancer. Now we have configured the default listener to send the traffic directly to the target group, thereby talking to our containers. So we'll send a GET request to our load balancer's URL or DNS. So first, let me find the DNS of our load balancer. If I go to NLB output.json, I should find the DNS name right here. So let me just copy this and take a new tab and paste it, and I will add misfits and I will hit enter, and here you go. I got the data. See, it's misfit and I got each misfit creature information. Very nice. Now that our load balancer and the containers are correctly working, let's attach this to our front end. So that is the final part of this video. So now we are going to update and replace the API endpoint of our front end. So I can go to module 2 web index.html, web and index HTML, and line 82 I should find the misfit API endpoint, and here let's replace our ELB endpoint up to this part and save the changes. Now we need to update our front end code in the S3 bucket. So in order to do that, let's use AWS S3 copy command, and I will copy this and paste it in. I have to replace my bucket name. My bucket name happened to be AWS Workshop app, so in your case it should be different, and I will paste it and hit enter. Okay, I think the upload is now successful. So now finally let's use our CloudFront URL. So this is our CloudFront URL, and right now I have these things hard coded in the S3. Since we have just uploaded the new S3 file, let's see if it loads the new one. Okay, looks like it did. Let me just double check this. I will go to inspect element and I will go to network and I enable XHR section and I will refresh the page. I should see a request going out to my ELB, and here we go. So this is the request. So this is my ELB DNS, and let's preview the result. There we go. So we got this from our backend. So if you got this far, congratulations, you have connected your front-end application with a back-end container through the load balancer. Well done. So I know it's been a long video, but we really need to get this far. So in the next video, we are going to use AWS CI/CD pipeline to automate deployment for our website. So I'll see you then. Thank you very much.